Hello, friends. This video is to explain some virtual circuit programming. I'm going to show you how I figured out how to make these dummies, which when I shoot, fall over and count towards a score. Hopefully it's capturing it in the camera there. There's one down. There's another down. And this one's going to count up. There we go. All right. So, first thing I want to explain about how I made this work is, I need the gun for this. And let's go into teleport mode. Nope. And you're going to need to follow me for this one, just 1 second. First person. There we are. So the first thing I want to explain about this is, here's my dummy. When you make a physical object normally in Rec Room, it defaults to the lowest density, and that doesn't work great for this, because if you shoot it, it would just blow it halfway across the map. So I had to turn the density up on this so that when I shoot it, it kind of falls over gently like that, rather than spinning over and over. And I think I can show. Let's do settings. Yeah, so you can see. I have to edit 1 second. Okay, so now if I go into settings, you can see this one's set on lithium density. So that's how I did that. If I turned it down, I think you can see. Oh, let's get done editing. Yeah. So that's why it has to be a pretty high density for it to be kind of realistic. All right. So now that's over with. He's down. Let's get onto the actual circuitry. See if I can get you a pretty good view. So these are the circuits. I'm going to go up here and show you the first, start at the beginning. I can't teleport down here anymore because they just made an update to the game. But, let's see if I can't get a good view. Okay. So the way I set these up to count whenever these are shot is, because in Rec Room currently there's no way to track when an object is shot with a laser or with a paintball. So the only way this tracks is just by the fact that it actually gets hit and knocked over. So I can tap this here. So because it's a triangle, it's in two dimensions. Anytime this falls over, it's got to hit one of these things. And these are object triggers, which are really easy to make, and I made them 1 centimeter wide. So they count whenever an object goes through, so this touches it, and it sends the signal along to count. Now, I had a few problems I had to solve that took a lot of experimenting to get right before I could really do this. That should be cleaning up. There it is. Okay. Let me see. So first of all, first problem to solve is there are 3 arrows on object triggers, right? So the first one, the first one activates right when something hits the zone. The second one keeps active so long as something is in the zone. And the third one activates when something that was in the zone leaves the zone. Now, the reason, so you notice I connected the circuitry up, and I'll explain the circuitry later on. I connected all of that up to the green arrow, and the reason for that is, hypothetically, well, theoretically, if I knock this, and it hit 2 of these, it could hit one. Let's see if I can do this gently to sort of demonstrate. It could hit one, and then later on come back and hit a second one, and that would count it twice, and I don't want that. I want to make sure that anytime it gets shot, that only counts for 1. That should be counting up over there. So, and I guess I'll have to explain a little bit by going down here. This is connected up to an OR circuit, right? So just understand that for the moment. So what that means is, if this is touching 2 at once, if the dummy's touching 2 of these at once, the OR circuit is only activated, it only shows the number 1, because it doesn't care how many. All it cares is that it's at least one of them. That wouldn't quite work if I had this connected to the red arrow, because it might touch one, and then it would send a pulse signal, and then touch the other one and send another pulse signal. That's the best I can explain that. So that's the problem I had to solve. That's why they're connected to the green arrows. Now, another sort of a more minor problem I came across, I can demonstrate over here. So here's an output. Let me connect this up. Yeah. I guess I'll finish explaining the OR circuit real quick. The OR circuit's pretty obvious. It's just if all 3 of these were hooked up and sending out pulses to the score counter anytime they were activated, then you would pretty frequently get scores double counted, and you don't want that. So I think that's understandable enough. So I hooked up an output here because something I just sort of discovered a problem. This is a problem with object trigger zones, right? I was testing this, and this was the OR circuit was outputting 1 even when I wasn't shooting this, and it was outputting it continuously, and I couldn't figure out why. And I looked at it, and I realized that's because trigger zones actually count as objects. So you notice when I move even just the arrow at the end, even when I move that into this trigger zone, you can see the output. That iterates it up 1. So something to be aware of when you're doing something like this is make sure that your trigger zones are not accidentally touching each other. And that's clear right there. It's not outputting anything. And again, so when I knock this over, it flashes 1 just for a second. Okay. So, and the final piece of circuitry is, this is, just make sure I haven't forgotten anything. Oh, and what I just explained is a good, that's a good lesson in why it's always nice to use output chips to diagnose problems, or even just have them hooked up so that you can see that numbers are what they're supposed to be as you're building something. So that's a real lesson I've learned and I wanted to share. And the next thing is, I'll explain the OR. So the reason this delay chip is here, let's get one of these shots. Anyway, so the reason that this delay chip is here is because this converts a steady signal into a pulse signal. Now, as I explained, the green arrow means that as long as something is in the trigger zone, it's outputting a signal of 1. And the problem with that is the game counts by ticks, 10 ticks per second, and that means that if my dummy is moving slowly and it's within the trigger zone for 0.2 of a second, 2 ticks, 2 server ticks, then what that's doing is it's totaling up the score for every tick that it's in there. So if it was in there for 2 server ticks, then that would be a continuous stream of 2 server ticks, and it would up the score twice for being in there, and I don't want that. So all a delay chip does is it only updates the value when the value changes. So as soon as the dummy goes into the trigger zone, it turns to 1, and no matter how long it stays there, it continues to be 1. But the delay chip only outputs the change for 1 tick and then goes back to 0. And so that's why it only counts once for every time it hits. And that's it. It's just trigger zones and 2 circuits, and then you can see over here. So, I can see over here that I've got both of these I've got my delay circuit here and my delay circuit there. This is the end of the circuitry connected up to a combinator, which just the way I have it wired here creates a loop, and so it just totals the number. Pulse signals come in here, pulse signals come in here, and then this one totals it, and it sends it out, and that's the number of times I've hit that, and I can reset that. Let's do that. To reset it, I'm just going to move this one, connect. Actually, let's do this one instead. All right. So all that did was send a signal to this reset button. And only one signal because it's delay chip, and now that's on 0. So, and that is how every time I shoot one of these, it counts the score, and I'm going to use this to make a competitive game. You see I've got red ones here. Not a very good shot. That's the low density one. I got red ones here and blue ones over here. The players on opposite teams can shoot them and rack up points until somebody wins. Combinator. All right, that's all I got. I'll check in next time I figure out how to build something complicated like this, and thanks for watching.